Hello and welcome back to our continued adventures on the Let's Defend platform. Today we are taking a whack at the free challenge browser exploit. It is for the security analyst path and it is medium difficulty. Analyze the provided JavaScript code for the browser exploit as a malware analyst. And so we get in there. The backstory is it's a busy Monday morning at your organization, and the IT security team receives an urgent alert. One of your web servers has been infected with malware. The infected server hosts a critical application and handles sensitive customer data. Upon investigation, the IT team determines that the malware is unknown and potentially sophisticated. In response, they isolate the infected server and escalate the incident to the malware analysis team for further investigation. And so we are given in the typical format a challenge folder on the desktop, challenge file, flashback.zip with the password of infected, and a couple of different questions. What function do you identify as responsible for converting input into a base 36 string? What is the name of the function that converts numbers to hexadecimal strings with specific formatting? What is the name of the array that stores developer div elements? What is the length of the array storing developer elements in decimal? If JavaScript is disabled in the browser, which endpoint is accessed instead? What's the name of the function responsible for triggering the exploit? What is the name of the flash file embedded within the code? And what is the CVE number assigned to this exploit? Alright, so I have there it is. Whoa. That just becomes ginormous. It's just a little bit too big. Takes over everything. And of course, I just had to touch it, and now it is just all over the place. Crap. Alright, so we'll transition over. And so basically, challenge file, tools as before, and every single time. They've got beautify and a bunch of other things. We get flashback from the extraction, and this is what we end up with. Your typical build out for a HTML file. So I know one of the questions was, okay, what happens if there's, what was it? If JavaScript is disabled in the browser, which endpoint is accessed instead? So that would be in the no script tags right off the bat. So that's going to be node.js.ph. Then we get our 3-day streak started. So we have that. Okay, so let's start at the top. What are we looking at here? We got this variable that's called through the rest of this stuff. So it looks like it's doing toString for, oh yeah, input base 60 or 36. So Davy HP, because then we have the toString and then 36. Or is it TRDP? Let's try this. Okay, that's right. Oh, I can move this over just a little bit more to make. There we go. So it makes it a little bit easier to see the correct when it comes through, or when it says incorrect. What is the name of the function that converts numbers to hexadecimal strings? What is the name of the function? toString. I didn't add an extra? Really? Maybe it's further in there. Function, return. No? I mean, that's what's calling it. Well, let's take a look. This looks like this is URL encoding. This variable MQQUHDZC. So we pop that into CyberChef to URL decode. Well, technically started with magic just to verify, and then we end up with a bunch of code that's inside here. So some obfuscation. Take that, we dump it into an online beautifier, and this is what we end up with. So let's take this then, and we're just going to open up another one, and we're just going to paste that in there. So there's all the code there. That way we've got everything that's just inside there. Okay, so what is going through? Oh, hello. Function. EY1. Is that what they're... No, really? What's the hint? Look for a function that takes a number and converts it to a string using a specific base 16. Okay, so where do we see base 16? I mean, to string. But the function is ey1rfx. Right? I mean, specific to. Here's our to string, and that's doing it to 16. Hmm. Okay, well, what else do we have? What is the name of the array that stores developer div elements? Just to make sure there's nothing else. Nope, this just returns back through there, okay? So then we would be looking for, like, what? Some sort of actual mention of div. So show me div. Oh, there's div. Line 14. So this would be G underscore ARR. Okay. What is the length of the array storing developer in decimals? So that's going to be the length here. So what is this in decimal? Add a new input tab, please. Yeah, we're not going to do URL decoding on that. Can you do some magic to do... Can we do conversion inside of CyberChef? You know, I don't think I've ever tried. 2 decimal. I don't think that's right. I don't think the answer is going to be what? 481,205,000 or whatever the case is going to be with that. I don't think that's quite right. And there might be a way to do it in how about 592? Asking Google to the rescue, apparently. Okay. What else we got with what we have? Let's see. We're looking for name of the function that is responsible for triggering the exploit. By tag name, create tag name, pen child, on page change fun. Yeah, I think it's this. PUIHA3. Okay. What's the name of the flash file that is embedded? And that is right here. E56 delta 2 dot SWF. What's the CVE number assigned to this exploit? Well, let's see if the flash file gives us anything. Oh, apparently there's a write-up for this one already. Let's defend browser exploit. That apparently confirms the answer, even though that's not what I'm looking for. There's really not that much. We got malware, don't need coffee. So let's take a look at the malware, don't need coffee. So CVE 2014-0322. Integrating exploit kits. So let's try that. Hooray. Now we just need to figure out this whole name of the function aspect. Okay. I mean, the only thing I see, because it's not toString and it's not the other portion that we did, the EY1 RFX, which actually does the string to toString for 16. The only other aspect that I see in here, since we start in the actual HTML file that we're given, is the variable mqqh. And that apparently was it. But that's a variable, not a function. So I don't know, maybe it's been a while since I've had to do JavaScript programming. But I mean, you would think, okay, what's technically calling that then? But then that would be the first answer that we gave. Technically, the answer to number one, that HDAVHP, because that goes through, even though that's still declared as a variable. And then you have function outlying of TRDPNTO, but that wasn't accepted, even though that does the toString. And that variable calls that function through this. And then all that URL encoded stuff turns into the... Okay, whatever. We got it, what they were looking for. I mean, realistically, I really would have thought it would have been this, considering the fact that it's... I mean, the hint says base 16. And, I mean, that's effectively what's going on. Whatever. Because, I mean, if this does to base 36, then should that not be the same? Whatever. We found what they were looking for, and we were able to answer it. So there we go. That has been the browser exploit challenge on the Let's Defend platform. Something nice and easy for what? Well, I've got other secret squirrel stuff I have to do for work, so. But quick, to the point, and I guess a decent refresher for trying to go through and take a look at JavaScript malware, because not seeing a whole heck of a lot of that in the day-to-day. But that's fine. So there we go. All that being said, no waffling. We'll get straight to it. I will see everybody in the next video.